In this video, we'll be talking about vectors. A vector is specifically a line segment that has a direction to it. The length of that line segment has a very specific name. It's called a magnitude. So this distance from here over to here is a specific length. That length has a magnitude. You can notice that this one here has a shorter magnitude, or is shorter and therefore has less of a magnitude. You'll also notice that there's a direction to this. This directs in one specific way, this directs in a slightly different way. Now, what's important about the magnitude and the direction, we'll talk about more in another video, but for this one, let's just talk about the basics on how to combine or manipulate two vectors together. So, operationally, if I have two separate vectors that look like these, and I'm looking for the u plus v, so the vector such that this vector adds to this vector, we're going to go ahead and basically take these two vectors and put them end to end, which means that I'm going to go ahead and start with this. This point right here is, I'm going to label it here at the same point. That is called the initial point. We then also have a terminal point right here. So I'm going to try and draw this as accurate as possible, so it's about to there. So we have an initial point, we have a terminal point, and then we have the arrow denoting which direction that it's going on. Because again, it could be going backwards like this. But in this case, that is the vector u. Then what I'm going to do is I'm going to take tail to end. So this point right here, I'm going to take the initial side of v, and I'm going to stick it right here, which means that if I can do this as accurately as possible, it should look something like that. So that's u and then v attached to the tail end of it as it continues going. So if I'm looking for u plus v should still be a vector. Two vectors added together should then provide me with still another vector. So that means from here, the start of the first vector to the end of the second vector. So I'm going to go from here to that location there. So this to this point here, that is u plus v. And again, note, it's important to start at the initial point of u and end at the terminal point of v. So u plus v, if I were to draw it null and void of everything else, it would look something like that. Okay, again, it might be a little bit not quite as parallel to that line as it should be, but that's what the vector should, give or take, look like. Let's talk about what negative vectors are. A negative vector does nothing more than changes the direction in which it's going. So if I draw this exact same magnitude initial point and then terminal point, but this time v has to have a negative in front of it, that means that the arrow is simply going to be on this end. So that means I'm starting here instead and ending here. So then the question is what is u minus v? Well, u minus v is not really anything in vector notation. It's more appropriately u plus a negative v. That's the way we're going to want to think about it. So what I'm going to do is I'm going to do the exact same thing I did up here. The only difference is I'm going to attach u, positive u, with a negative v going the opposite direction. So that means I'm going to have something that looks like something like this. There's my u, give or take, and my v is something give or take like this. Sorry, it's there we go. So this point here, initial point of u to the ending point of v. So I should be going here. That should be u minus v. So again, this vector that looks more like this, that is the vector of u minus v. The last thing I want to talk about in this particular video is the concept of a scalar. That's what we call that 3 in front of v. That's a multiplicative scale of what v is. So what we're going to do is we're going to actually take the vector v, which is again this vector right here, and we're simply going to draw it tail to end 3 times, because 3v is really nothing more than v plus v plus v. So it should look something along the lines of this. So there's 1v, there's 2v, and there's 3v. So all of this from here all the way to here is 3v. Now, it's important to note that I didn't draw any of these vectors on a coordinate plane. The reason why I didn't draw these vectors on a coordinate plane is because vectors don't have any specific location of where they start to where they end. Some of them may be defined that way, but the vector is nothing more than 2 specific definitions. It's the magnitude tied with a direction. Okay, so don't assume that these vectors have to sit in any one specific on the origin or in the coordinate plane. Again, I drew them specifically null and void of a coordinate plane because they don't have any distinction in the way that they're defined. Again, they could be defined by 2 points and 1 initial point and 1 terminal point. But that doesn't mean that that vector is null and void of all other vectors that have the same length and the same direction.